Okay, so in the last series of videos, we learned how to solve quadratic equations that we were unable to factor with the Xbox or area model method. The method you learned to solve those types of equations is called completing the square. So, in my opinion, completing the square is kind of a pain. Luckily, there's a formulaic approach for completing the square, and it's called the quadratic formula. So, in this video, you will learn when you can apply the quadratic formula, so when it's appropriate to apply it, the formula itself, and also how we actually apply the formula. The video after this shows how the quadratic formula is derived by completing the square on a general quadratic trinomial. And that's something that you should definitely view so you can see the connection between what we did in the previous video and or video series and this video that we're going to look at today. All right, so let's get started. All right, so the first thing, the quadratic formula works for equations that are in standard form. So this is the type of equation that you're going to be solving using the quadratic formula. So there's a couple things. First thing, obviously, it's a quadratic trinomial that's on the left-hand side of the equation. So we get a pen. So again, we'll focus on the left-hand side of the equation. There's a quadratic trinomial that's in standard form. And again, what I mean by standard form is that the degrees are in decreasing order as we move from left to right. So you start off with the second degree, first degree, and then a constant term. All right, so we have to set up our quadratic trinomial in that manner and make sure that it's set equal to 0. And then we'll be able to apply the quadratic formula. So let's see what the quadratic formula is. So the quadratic formula is down here. All right. So you can use the quadratic formula to find the solutions to a quadratic equation in standard form, as I just mentioned, and that's the form that we recorded above. The directions for this follow along with the video, so you'd want to pause the video right now and make sure that you record this. All right, so here's how the formula works. So the formula is on the right, and I'm going to highlight that for you right now. So here's the formula. And you'll notice that there's a combination of variables and constant values in there. So you see A's, B's, and C's. So the A value is the coefficient of the quadratic term. The B value is the coefficient of the linear term. And the C value that you see in the formula is the coefficient of the constant term. And I don't know why that didn't change color, but we'll leave it alone. All right. Now, here's something interesting about quadratic equations. There's really three different types of solution sets that you can expect to get when you're solving a quadratic, whether you can solve it by factoring or by using the quadratic formula or completing the square. Okay, so you might get one real rational root. And if we think about this graphically, that's when the parabola comes down and its vertex hits the x-axis at exactly one spot. Now, that's only going to happen when we're dealing with perfect square trinomials. So if you have a perfect square trinomial, you're going to get one real solution. You could get two real roots, so they could be irrational or rational. And we'll kind of talk about what irrational roots are in this video. Okay. Now, this is a scenario where the parabola hits the x-axis at two distinct different points. And then it's also possible that you'll get no real roots, or these things that we call imaginary or complex roots. So we haven't learned imaginary or complex roots yet, but graphically, this is when the graph of the parabola does not hit the x-axis at all. So we're actually going to see a couple different. I'm going to go through three examples right now. We're not going to look at one where there's one real rational root, but we'll look at an example where there's two real roots, one that's rational, one that's irrational, and then two imaginary roots. All right, so let's go ahead and take a look at some examples. All right, so we're going to focus our attention on example number 1 first. All right, so for these examples below, the directions would read solve the quadratic equation using the quadratic formula. So that's what we're going to try and do. So I'm going to write the quadratic formula off here to the right-hand side. Let me get a pen because it's not working. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, you look at this formula and like, wow, where did this come from? Like I said, the next video that I'm going to post will show you exactly where that formula comes from. And really, it's just from completing the square. All right, so let's get started on this. X equals. All right, so the first thing that we're going to want to figure out, what are the values of A, B, and C? So if we look at our quadratic, it's written in standard form. The degrees are written, excuse me, the terms are written in descending order in terms of degree. So let's look at what each of the values are. A in this case is going to be 1. B is going to be 4. C is going to be negative 21. So anywhere we see an A, we're going to replace that with a 1. Anywhere we see a B, we're going to replace that with a 4. Anywhere we see a C, we're going to replace that with negative 21. So let's go ahead and do that. So this is going to be negative 4 plus or minus the square root of B squared. So that's 4 squared, so 16, minus 4 times A, which is 1, times C, which is negative 21. Okay, and all that needs to be evaluated before we take the square root of that result. And that's going to be all over 2 times 1. All right, so now we're going to go ahead and evaluate this. We're going to get x equals negative 4. Now let's evaluate what's underneath that radical. So 16 minus 4 times 1 times negative 21, that's actually going to evaluate to 100. So this is plus or minus the square root of 100 all over 2. Now, if you can, right now we're going to try to simplify this down. The square root of 100, that's actually a perfect value. So we're going to get negative 4 plus or minus 10 over 2. All right, so right now we know we're going to get 2 roots, and let me show you why that is. Let me grab a pen, different color pen. So the first root that we're going to see is negative 4 plus 10, then divide that by 2, negative 4 minus 10, and divide that by 2. So x is going to equal negative 4 plus 10 over 2, which evaluates to 3. Negative 4 plus 10 is 6. 6 divided by 2 is 3. And then x is also going to equal negative 4 minus 10 over 2. Negative 4 minus 10 is negative 14 divided by 2 is negative 7. So in this case, we get 2 roots, and I'm going to write those over on the left-hand side because I ran out of space. X equals 3 or x equals negative 7. So those are the 2 solutions to this equation. Now you can check this a couple different ways. You can plug 3 back into the original equation, and the left-hand side should equal 0, and the same thing for x equals negative 7. If you plug that in, you should get 0 on the left-hand side. You can also check this out graphically, and the graph of x squared plus 4x minus 21 should intersect the x-axis twice at x equals 3 or negative 7. And this is an example where we get 2 real rational roots. So 2 real rational roots. And really what that means are rational numbers are just ratios of integer values. So they're kind of like the nice solutions, whether they're just whole numbers or negative whole numbers, or nice fractional values. The next example that we're going to take a look at, that's not going to be the case. You're not going to get rational roots. And I'm going to tell you what you do when you get an irrational solution. You're basically just going to take, for now, a decimal approximation. So let's go ahead and take a look at problem number 2. Now, I'm not going to rewrite the quadratic formula again because we have it right here. So we're just going to reference the quadratic formula right there to do this problem. So let's do it. All right, so same thing. X is going to equal negative b. So b in this case is 12, so it's going to be negative 12 plus or minus the square root of b squared, which is 144, minus 4 times negative 3 times positive 1. And that's going to be all over 2 times negative 3. All right, so now again, it's just a matter of kind of simplifying things. I'm just going to grab a different color pen so we can see the different steps. So x now is going to equal -12 plus or minus. All right, we have to evaluate what's underneath the square root. So it's going to be 144 minus 4 minus 3 times 1. So that's going to evaluate to 156. You can do that in your calculator if you have to. And that's going to be all over 2 times -3, which is -6. All right, so here's why you're going to get irrational solutions on this one. 156 is not a perfect square. Probably sometime next week we're going to, or maybe the week after, we're going to start talking about how to simplify radical expressions. Right now you just don't know how to do that. So when you get an irrational solution like this, you're going to have to take a decimal approximation. In the future we can kind of simplify this down and leave this in a more exact in exact terms where we simplify the radicals. Again, that's something that you don't have to worry about now, but it's something that we'll address later. All right, so right now we're just going to take a decimal approximation of our solutions. So let me write out the solutions in a different color. So x is going to equal -12 plus the square root of 156 all over -6. And when we reduce that or get a decimal approximation, you get -0.82. The second one, x equals -12 minus the square root of 156 all over -6. When you take a decimal approximation of that, you get roughly 4.08. So right now, rounding to 2 decimal places is appropriate unless you're told otherwise. Now, again, this is going to involve you doing this in your calculator. I don't know which calculators you have, so it's going to take a little bit of practice. Um, Again, what I would do is check your answers graphically. That's a really easy way to do it using Desmos right now, just to make sure that you're using the calculator properly. All right, so we've looked at 2 examples of how to use the quadratic formula. The first example, we get 2 real rational roots. The second example, we get 2 real irrational roots. Let's take a look at a third example. All right, we get 3x squared plus 6x equals -10. So the first thing that you're probably noticing here is that you have a constant value on the right-hand side of the equation, and it's not set equal to 0. So we're going to add 10 to both sides, and that's going to give us 3x squared plus 6x plus 10 is equal to 0. All right, so now we're just going to kind of follow through exact same process. We're going to use the quadratic formula for this. So x equals -6 plus or minus the square root of b squared, which is going to be 36 minus 4 times a, which is 3, times c, which is 10. And I apologize that my computer is acting up on me a little bit. I'm not registering this accurately, so just make sure that you're following along. And that's going to be over 2a, so 2 times 3. Okay, now we're going to go up here a little bit. And let me grab a different color. And what we're going to get is x equals -6 plus or minus the square root of. All right, so 36 minus 4 times 3 times 10 is actually going to give us a negative number. So that's -231. And that's going to be over 6. All right, so here's where we start running into problems. If we have a negative square root, or a square root of a negative number, I should say, it's more appropriate. What that's telling us is that there are no real solutions to this equation. So what you should do is write no real solutions. And that looks terrible. I apologize. That says solutions. All right. So here's the deal. I'm going to kind of give you a brief overview of what this means. There is no real number that you can multiply times itself to get -231. In fact, there's no real number that you can multiply times itself to give you a negative number. If you multiply 2 positive numbers together, you get a positive value. You multiply 2 negative numbers together, you also get a positive value. However, there are numbers called imaginary numbers um, that help us solve problems like this. Instead of us having to write no real solutions, there's a way that we can express that solution set. That's not something that you're really going to learn about probably until you get into Algebra 2. All right. But for now, if you encounter a problem where you give a negative or the square root of a negative number, all right, you're going to write no solutions. Now, the cool thing is that the quadratic formula gives you another approach for solving quadratic equations. For me, I always check to see if the quadratic can factor. So, like if you take a look at number one, and I'm just going to erase this stuff here. You take a look at number one, that one is actually factorable. Okay, so I would have attempted to factor that first, just because I think factoring is more efficient, um, and there's less chance of making arithmetic errors, because that's kind of the problem with the quadratic formula is people will make arithmetic errors. So I always try to factor first, and if I can't factor, that's when I'll use the quadratic formula. So the cool thing about the quadratic formula, even if you look at the quadratic that you're working with and it will factor, but you don't recognize that it will factor, the quadratic formula will always get you the solutions because it's just a formulaic version of completing the square. And as I mentioned in the previous video, completing the square will help you get the solutions to any quadratic equation. All right, so I hope this was helpful. Like I said, go ahead now and watch the second. Actually, you should probably practice first and then go and watch the second video. And it'll show you exactly where this formula comes from. It's a pretty interesting video. All right, I will talk to you guys soon, and we will see you in the next video.